Hello everyone. In the last video, I have discussed about this submerged unit weight. Related to that, one important note point I'll discuss, and then I'll move it to the unit weights decreasing order. So, for example, this is a ground surface. We are considering a soil. So, this is nothing but the water table. This is the symbol of water table, and here the soil is capillary saturated. Okay, here it is submerged. So the zone below the water table is submerged, and the zone above the water table, the soil is capillary saturated. The means the pores which are there in the soil are filled with capillary water. So what is that note point? Here one important point we have to remember, that I will write. So all saturated conditions are not submerged conditions. So first let me write, then I'll explain. All saturated conditions are not submerged conditions. Here capillary saturation zone can be taken as or considered as saturated zone but not submerged zone. So here you can clearly see that I have explained, like here this is the ground surface of the soil that we have considered, and here is the water table, and this is the zone which is uh, in the soil. The pores are capillary saturated, means in that pores capillary water is there. That means it is saturated but it is not submerged. So whenever in the problem or anywhere, if they have given saturated, then it is saturated only. When we are considering unit weights, we should consider saturated unit weight only. We should not take the submerged unit weight there. So if they mention that the soil is under submergence, then only we should take or consider submerged unit weight. So without the information, we should not consider the submerged unit weight. That is why here I have written capillary saturation zone can be taken as a saturated zone only. That means in this area, in the problem, we should take gamma sat value but not gamma submerged value. We should take gamma saturated value but not gamma submerged value. So that's why I have mentioned capillary saturation zone can be taken as a saturated zone only but not submerged zone, because it is not under submergence. So that is one thing. And the next thing will be like so okay. So Next thing. So hope we have cleared all the unit weights. So now I'll uh, write the unit weights which we have discussed till now in the descending order. That means highest unit weight to lowest unit weight for a given soil. Okay. So what we have discussed, gamma dry we have discussed. Okay. Okay. Gamma dry we have discussed, gamma saturated we have discussed, and gamma submerged we have discussed, and bulk unit weight gamma T or gamma B and gamma S. So for a given soil, for a given soil, so for a given soil, given soil, arrange all these, all these means all these unit weights, all these unit weights in the descending order. Descending order, descending order is nothing but highest to lowest. So if you arrange this, so this is constant for a given soil, this you should remember. First unit weight of soil solids, next saturated unit weight, next bulk unit weight, next dried unit weight, and next submerged unit weight. So I'm arranging in the descending order, that means highest to lowest. So this is one important relation, this is one important relation, this is constant for a given soil. Okay, this is constant for a given soil. So I'll discuss briefly what we have discussed. So submerged unit weight node point we have discussed, and the unit weights, order of unit weights for a given soil we have discussed. So this is very important, some in some examinations and all, so they will directly ask what is the descending order. So I have written here descending order, you can write ascending order as well. So yes, so now this is completed. In the next video I'll discuss about specific gravity, what is specific gravity, and what is its importance in geotechnical engineering, and different types of specific gravities, like mass specific gravity, and two more specific gravities are there. So that I will discuss. After discussing this specific gravity concept, I'll derive some of the important soil water relationships. Weight of solids is equal to total weight by 1 plus water content. So like this, some 12 to 13 relationships are there. Those relationships are very important for solving questions and all. So for each and every relationship I will derive till its completion, and after that only I'll solve some numericals on this soil water relationships. So later one by one concept I'll discuss in each video. So thanks for watching. For more videos please subscribe to my channel. Thank you.